So I've been having a lot of students ask me, how do you count? Like they saw my video on orbital diagram and an electron configuration, which I highly recommend. So go check that out if you don't know how to do it. But they say, where do you get, for example, 3D10 from or 2p6 from? So again, let's count together. This is the S block. Again, this is also part of the S block. This is the D block. This is the P block. And this is the F block, in case you didn't watch my video. Now, let's begin counting. 1s1, 1s2, 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Let's pause. Let's go back a little bit. Let's say what I wanted to count was boron. When I write the configuration, I'm not just going to write 2p1. I'm going to write 1s2, 2s2, 2p1. If I want to do carbon, I would do 1s2, 2s2, 2p2. Let's go back further. If I want to do helium, it's going to be 1s2. If I do hydrogen, it's 1s1. If I do lithium, it's 1s2, 2s1. And again, I'm going by the row, okay? Lithium is on the second row. It's going to be 1s2 because I passed hydrogen and helium, 2s1 because now I'm at lithium. So lithium's electron configuration is 1s2, 2s1. For beryllium, it's 1s2, 2s2. Again, for boron is 1s2, 2s2, 2p1. Let's say I want to go to oxygen. Okay, it's going to be 1s2, 2s2, 2p4. Okay, then I can go to fluorine, and then I can go to neon. Now, again, I ended at 2p6. So if I didn't want to write the whole thing, 1s2, 2s2, 2p6, I could write neon in brackets. Again, if I go here and I go to sodium, it's 1s2, 2s2, 2p6, 3s1. I could write the whole thing, 1s2, 2s2, 2p6, 3s1. Or I could write neon in brackets, Ne in brackets, 3s1. Either or. One is the noble gas configuration and one is the regular electron configuration. Now, this is going to be 3s2, 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. Okay? Now, here are where things get weird. Okay? When you go to the fourth row, you have 4s1, 4s2, like normal. But there are a couple cases that change. The other thing that you need to know is that when you go to the D block, you drop down. So it's going to be 4s1, 4s2 with calcium, 3d1. And then this is 3d2. And then this is 3d3. Now, with chromium, things change. And it's almost always a trick question that they have on the exam. So, what is electron configuration? Well, one of these from the S go over to the D. So what ends up happening is you have 3p6, 4s1, 3d5. I know that's very strange, but that's one of the exceptions that you need to know. Then when you go to manganese, it's the same thing. It's going to be 4s2, 3d1, 3d2, 3d3, 3d4, 3d5. So I'm going to write here in chromium, I'm going to circle it. This is going to be an exception that you need to know. Okay, then you go to, again, 3d5, 3d6, 3d7, 3d8, and then this copper is another exception. Again, you're only going to have one from the S, so it's going to be 4s1. It's not going to be 4s2. It's going to be 4s1, 3d10. And again, it's just something that you need to know. And then this goes to 4s2, 3d10. So I'm going to make emphasis. On chromium, what you're going to have is going to be, I'm going to do the noble gas configuration and show you. You're going to have your argon, and then you're going to have 4s1, and you're going to have 3d5. Then when you go over to copper, you're going to have, again, argon, 4s1, 3d, and then you're going to have 10. And then your zinc, the way that you're going to know that it's different is because you're going to have, again, your argon, 4s2, 3d, 10. And then you continue your configuration and you're going to go back. Let's do gallium now. You go back, and then again, it's going to be, again, argon, 4s2, 3d10. And then you're going to go 4p1. So again, I'm going to write now for argon, 4s2, 3d10, and then again 4p1. So I hope this helps you understand how to do electron configuration.